Section 2.3, Set Operations and Venn Diagrams. Let's start off by looking at some definitions. First definition is the intersection of two sets. The intersection of sets A and B, denoted by this notation right here, that means intersection, is the set of all elements common to both A and B. In other words, to get into the intersection of these two sets, you must be in set A and you also must be in set B. This is the part where they overlap each other. And the next definition said the union of two sets. The union of sets A and B, denoted by this notation, this right here means union, is the set that contains all the elements that belong to either A or to B or maybe to both. To get into the union of two sets, you don't have to be in both of them. You just have to be in one or the other. It's okay to be in both of them. You can still get into the union, but you just have to be in either A or B to get into this union of two sets. You have to be in both A and B to get up here into the intersection of the two sets. By the way, this kind of looks like the letter U, although it's not. The letter U we will use as universal set. So this is not the letter U. We will also, in this section, talk about Venn diagrams. I'm sure most of you have seen Venn diagrams before. They are named after this English mathematician, John Venn, from the 1800s. We will look at many Venn diagrams today, but here are a few common Venn diagrams right here. These are 9 of the most common Venn diagrams that show up. We will get more into this in a little bit. Sometimes Venn diagrams have more than 2 circles. We will see that also. There's something called De Morgan's laws, named after Augustus De Morgan, a British mathematician from the 1800s. And he noticed that these relationships hold. This is true. This says the complement of the unions is equal to the intersection of the complements. Let me say that again. The complement of the union is equal to the intersection of the complements. And similarly, the complement of the intersection is equal to the union of the complements. The complement of the intersection is equal to the union of the complements. And before we start our examples on the paper here, here is a 3-circle Venn diagram. And we will look at some of those also. Let's consider that there is a math club on campus and also a chess club on campus. The math club consists of 1, 2, 3, 4, 5, 6, 7 people. Chess club consists of 1, 2, 3, 4, 5, 6 people. Using some of the notation we've learned recently, we could say the number of elements in the math club equals to 7, and the number of elements of the chess club equals to 6. Let's assume the math club and the chess club want to go on a field trip, like a joint field trip. And the rules for this field trip are that you must be in the math club or the chess club. How many people get to go on this field trip? So to go on this field trip, you just have to be in one club or the other. Now, some people would say, well, 7 people in this club and 6 people in this club. I guess there's going to be 7 plus 6. I guess 13 people are going. Not necessarily. That's probably a pretty common answer I might get is 13 because that is 7 plus 6, right? But why is it not 13? Think about why the answer is not going to be 13. And it's because there's some sort of overlap, right? Some people are in both clubs. Like look at Ivy. Well, why would we need to buy 2 tickets for Ivy? Look at Bree. Look at Zoe. So some of those people are we don't need to buy 2 tickets for Ivy. We don't need to buy 2 tickets for Bree. We don't need to buy 2 tickets for Zoe. If we bought 13 tickets, we'd have like 3 extra, I think, because we double counted some people, right? So since there's 3 people in the overlap, I think there's actually only 10 people that are going on this trip, right? I mean, who are those 10 people going on the trip? I mean, to be honest, we're actually talking about the union of these two um, clubs. The union of these 2 clubs would be Fitz. We abbreviate here Fitz, Ivy, Leon, Bree, Ted, Zoe, Nora. That's the entire math club right there. Then we need a ticket for Mia. We definitely need a ticket for Joe. But I don't need a ticket for Ivy. We already have Ivy accounted for. I don't need to buy another ticket for Bree. We already have Bree accounted for. I do need one for Owen, but I don't need one for Zoe. Zoe's already there. There's 10 people here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There would be 10 people going on this trip. Even though 7 plus 6 is 13, you don't want to count people twice. It's the 7 in the math club plus these other 3 that were not accounted for yet. And there's no reason to count these 3 again, Ivy, Bree, and Zoe. So that's called the union of the 2 sets. To get into the union of the 2 sets, you just have to be in one or the other. You might be in both, that's fine, but you just have to be in one or the other. As opposed to the intersection of 2 sets. If we're going to talk about the intersection of 2 sets, let's look at part B. Now let's assume the math club and chess club are planning a field trip, but the rules are different. To go on this trip, you must be in both the math club and the chess club. You have to be in both clubs to go on this trip. This is a much more exclusive trip. And I think you can imagine there's only 3 people get to go on this one. Those are the 3 people that we underlined up here, Ivy, Bree, and Zoe, right? Ivy, Bree, and Zoe are the only people that are in both math club and chess club at the same time. They are in what we call the intersection of the 2 sets. So what we're talking about here, I didn't really ask for it, but what we're talking about here is the intersection of these 2 sets. That means intersection. To get into the intersection, you have to be in both. And so that would just be Ivy, Bree, and Zoe. Those are the only 3 people that are in both clubs at the same time. And so what we're describing down here in part B is we're describing the intersection of the 2 sets. What we were describing in part A was the union of the 2 sets. Okay, so when I see union, again, that is not the letter U. You know, it kind of looks like it, but it's not. When we use the letter U, we mean universal set. This means M union C. But when I see union, I think or, because to get into this, you just have to be in one or the other. When I see this symbol, this is intersection, I think and, because to get into this set, you have to be in both the math club and you have to be in the chess club at the same time. Okay. Let's actually look at a Venn diagram for this example. So I think most of you have seen Venn diagrams before, right? Most of you have seen Venn diagrams before. Let me kind of go back and forth between the 2 pages. So I'm actually going to call this the math club, kind of pre-labeled A and B most of the time, but we'll call this math club and we'll call the right-hand circle the chess club circle. Okay. Well, let's start with the 3 people that are in both, right? Ivy, Bree, and Zoe are in both. So Ivy, Bree, and Zoe need to be in both circles at the same time. right? And so the only way to get them in both circles at the same time is to put them right there in the middle, right? This is where the circles overlap each other, right? I mean, that's what we were talking about down here. So the intersection of the two circles, the two sets, is that middle part where they overlap each other. That's where Ivy, Bree, and Zoe need to be put. Um, what about like Fitz and Leon and Ted and Nora? Those four people are in the math club, but they were not in the chess club. So Fitz, Leon, Ted, and Nora, they need to be over here, right? Fitz, Leon, Ted, and Nora. They need to be in the math club circle, but not in the part where it also overlaps with chess club because they're not in the chess club. And then finally, Mia, Joe, and Owen need to be over in this part, right? Mia, Joe, Owen. They're in the chess club, but they're not in the math club, so we don't want to put them in the part where it overlaps with both. Now, if there was somebody else that was like going to the school but not in either club, and we wanted to include them, we would put them on the outside. So sometimes you'll see people show up on the outside. This whole rectangle is considered our universal set, by the way. A lot of times we'll put like a U there or something like that. So there might be some other person over here, meaning they're not in either circle, but we're not going to do that for this example. So that's our first look at a Venn diagram. I think most of you have seen a Venn diagram before. Come back to Venn diagrams in a minute. Let's look at this next example. Let U be the set consisting of 1, 2, 3, 4, 5, 6, 7, 8. And then we also define set A, set B, set C. Remember, anytime we use the letter U to denote a set, we are talking about the universal set. Remember, that means as far as this problem is concerned, those are the only numbers in the world. As far as it matters to us for this particular problem, the only numbers that exist in the world are 1, 2, 3, 4, 5, 6, 7, 8, and that's it. That's going to be necessary once we start looking at complements. Okay, so this apostrophe thing here, that's something we learned in an earlier section. So when we start looking at complements, we're going to need to refer to the universal set. But for the first question, it says A union C. To get into A union C, remember that to get into the union of two sets, you just have to be in one or the other. You don't necessarily have to be in both. When you are doing A union C, you're just taking everyone in A and sticking them in there, but you're also taking everyone in C and you're sticking them in there. It's very easy to get into A union C because you just have to be in either A or C. You just kind of throw in A and C together, making one big team out of A and C. So there's all the A people got in there, all the C people got in there, we're done, right? To get into the union, you just have to be in one or the other. You don't have to be in both. But to get into the intersection, remember this says A intersection C. To get into the intersection of two sets, you do have to be in both. So the only people who are going to get into this one are people who are in A, but they're also in C at the same time. So what numbers are in A and they're also in C at the same time? That's who needs to go in here. And unfortunately, I don't actually see anybody that is in both A and C at the same time, right? 1, 2, 3 is in A, 5, 6, 7 is in C. There is no overlap between those two. And so this is actually going to be empty. So that's something else we've learned in an earlier section is learned about empty sets. So sometimes our answer is the empty set. And remember, we can denote it that way, or we can denote it that way. Those are both good answers. Okay. All right, the next part, part C, says, let's talk about A union C, but then the complement of all that. It's the complement of A union C. The complement of A union C means, remember, that means the opposite of A union C. It means everybody that's not in A union C. Now, luckily, we've just done A union C up here. We know what A union C looks like. So for our answer down here, it's basically going to be the opposite of what we got up here. The answer to part C here is going to be basically the opposite of what we got in this answer. That means everybody that's not in here when compared to the universal set. Okay? So luckily, we already know what A union C looks like. Now let's take the complement of that. So A union C looks like this. So who's not in here when we compare it to the universal set? Well, 1, 2, 3. Well, 4 is not in here. 5, 6, 7. Well, 8 is not in here. So 4 comma 8, that set represents the complement of A union C, the opposite of A union C. It's the opposite of this set, is what we wrote here, when compared back to the universal set. So anytime you do something with complement, you're comparing back to the universal set. Let's look at part D. This one says B intersects C and then the complement of that whole thing. The complement of B intersects C. I think it's a good idea to figure out what B intersects C looks like first. We had already done that. I didn't have to do that down here because I already knew what A union C looked like because that was already asked. But B intersects C has not been asked yet. So let's go figure out what B intersects C might look like. Then we can talk about the complement. So B intersects C means, remember, intersect means you have to be in both at the same time, the overlap of those two. So who's in the overlap of those two groups? I think it's just the number 5. And we're comparing B and C, and we're trying to figure out who's in both B and C at the same time. I think it's just the number 5. So B intersect C is just the number 5. Now, that's not my final answer, of course, because I still have to take the complement of that. That's what the apostrophe means there. It means my final answer is going to be the opposite of B intersects C. But B intersects C definitely consists of the number 5. But what's the opposite of that? That means now to take the complement of that, you have to go back to the universal set and list everything except for this, right? It's everything that's not in this group when we compare it to the universal set. So that would be everything except the 5, right? Like 1, 2, 3, 4, and then 6, 7, 8. That's my final answer. That's the complement of B intersect C, because B intersect C consisted only of the number 5. That was the only thing that was in both B and C at the same time. And then this apostrophe means go take the opposite of that set when compared to the universal set. For the next question, let's go ahead and take it by parts. Like, I think it'd be really hard to try to do this all at once. I think we should do this. So when I see the C, I know C is 5, 6, 7. That was given. That's going to be intersected with something. What's that going to be intersected with? Well, let's go figure out what A union B looks like. We still have to do a complement also, but let's go figure out what A union B looks like. A union B just means throw all these together in one set. Throw all the A stuff and all the B stuff, throw them in one set. Because remember, this means or. Just to get into this one, you just have to be in one or the other. So all of the A people get in here. So 1, 2, 3 gets in here, but then 3, 4, 5 also gets in here, but I don't need to list 3 again. Don't double list things. Okay. So 1, 2, 3 gets into the union. 3, 4, 5 gets into the union. That is A union B right there. Of course, we still have the complement to worry about. We still have to worry about that apostrophe, which means complement of that set. So C is 5, 6, 7. That was given to us. At some point, I'm going to intersect that with something else. But let's go figure out the complement of 1, 2, 3, 4, 5. The complement of 1, 2, 3, 4, 5 means the opposite of 1, 2, 3, 4, 5. Means everything not in this set when I compare it up here with U. So 1, 2, 3, 4, 5 is right there. That means 6, 7, 8 is missing, right? 6, 7, 8 is missing. So the complement means tell me what's missing out of there. That's the 6, 7, 8. Complement means opposite of that set. The opposite of 1, 2, 3, 4, 5 is the rest of the stuff, the 6, 7, 8 right there. And finally, remember this one, this symbol means intersection. That means my final answer is going to be everybody who's in both of these sets at the same time. So it means the overlap. It means to get into this final answer, you have to show up here, but you also have to show up here. Okay, this is an intersection. This is not a union. This is a more exclusive club. Harder to get into this group. It's harder to get into this group because you have to be in both at the same time. And only the 6 and 7 are going to get into this final answer, right? Because only the 6 and the 7 are in both of those at the same time. 5 doesn't get here because 5 doesn't show up in this one. And the 8 doesn't get here because 8 doesn't show up in that one. For the last several examples, we're going to focus on Venn diagrams. Um, Actually, before I do that, I think maybe it's a good uh, time to quickly, maybe over here on the side, I can look at a first three circle Venn diagram. Um, so when we draw the big rectangle, that's our universal set right there. A three circle Venn diagram usually looks like this. A, B, C. And let me draw a three circle Venn diagram for this situation. For example, A consists of 1, 2, 3, right? I can put 1 and 2, and I can put 3, but let's be careful where we put 3 because I need to put 3 so that it's also in the B circle. But I don't want to put it in the part that also overlaps with the C circle. I do want it to be in both the A and the B circle at the same time. So I think 3 would need to go hang out up there. And then the 4 and the 5 need to be in the B circle. The 4 is good to put right here, but notice the 5 also must show up in the C circle. So I need to put the 5 in the place where the B and C overlap, but I don't want to put 5 right there because it's not in the A circle. So 5 needs to go right there. 5 needs to be in both the B and the C at the same time, but not in the part that also overlaps with A, not in that middle part. And I believe 6 and 7 would be over here only in the C circle. We're almost done, except the number 8 should be there somewhere. The number 8 is in the universal set, but it's not in any of these sets. That's where we just throw 8 somewhere on the outside. It's still in the universal set. It's still in the rectangle. It's just not in any of the circles. So that's what a Venn diagram would look like for this particular situation here. Let's continue to focus on Venn diagrams. This next example says, draw a Venn diagram to show each of the following sets. Draw a Venn diagram to show each of the following sets. What we mean by that is we want to like shade in the Venn diagram so that A union B is what we have shaded. So to get into the union of two sets, you just have to be in A or B. You don't have to necessarily be in both, but you might be. It's okay to be in both, but you just have to be in one circle or the other. So I want to shade everything in this picture that's just in one circle or the other. So like, for example, the whole A circle is going to get shaded because that's the whole A circle right there. But then also the B circle should be shaded. That's A union B right there. That's the union of the two sets. Intersection of the two sets for this one, get into the intersection of the two sets, you have to be in both. You have to be in A and B at the same time. It's harder to get into the intersection of the two sets. You have to be in both A and B at the same time. That's the overlap part right there. That represents the intersection of sets A and B. Get into this one, the union, you just have to be in one or the other. It's okay to be in both, but we shaded everything that's in one circle or the other. But to get into this answer, you have to be in both A and B at the same time. That's the middle part. That's the overlap part. To get into this answer, this says A complement. To get into A complement, that means you're just not in the A circle. So let's shade everything now that's not in the A circle. Now, what I see sometimes I see people do is they say, well, here's the A circle, but this part is not in the A circle right there. That's not my final answer though, because there's the rest of the rectangle that's also not in the A circle. So my final answer is not just that. This part out here is also still part of the universal set, but not in the A circle. So sometimes the outside stuff gets shaded also. That would be the correct answer for A complement. A complement means the opposite of A. We just shaded the opposite of the A circle. We just shaded everything not in the A circle. What about this one? To get into this answer, this is the complement of A union B. Now I want to shade here the opposite of A union B. Luckily, we just did A union B up here, so these two pictures should be opposites of each other. What's shaded down here should be the opposite of what was shaded up here, right? Because here's A union B, here's the opposite or the complement of A union B. So if A union B represents this, then the complement of that would just be all the stuff not in the circles, right? Complement would be all the stuff on the outsides here. So notice how these two are opposites of each other, right? Here's A union B. Here's the opposite or the complement of A union B. As far as shading goes, we shaded opposite things on those two pictures. That's what complement means. Um, we have a couple more of those. I left a little more room on this example because I think on sometimes we don't want to try to get our answer right away really fast. Sometimes I think it's better to take little steps. What I mean by that is this. Um, we're trying to find the intersection of A complement and B complement. I think it might be a good idea to look at A complement and look at B complement and then talk about their intersection. Okay. Because what does A complement look like? A complement, we actually just did that on the last page, but let me remind you. We actually just did A complement right up here. A complement was this. It's everything not in the A circle, right? So A complement did include this part, but it also included all of this. That was A complement. You saw that right here. And similarly, B complement would be everything not in the B circle. This is not in the B circle, but this is also not in the B circle. That's what B complement would look like, right? It's everything except for the B circle. So I took A complement here, I took B complement here. What I'm supposed to do is intersect those two. I'm intersecting those two. That means my final answer is going to be the overlap of these two. My final answer is going to be only the things that are shaded in both circles at the same time. Notice that the outside part is shaded in both, I think I said circles, I meant Venn diagrams. Uh, my answer is going to be whatever is shaded in both Venn diagrams at the same time. Like, where does the shading overlap each other? Notice that the outside part is shaded in both. So the outside part is going to get into the intersection. Um, this. Notice that this right side of B is shaded here, but it's not shaded here. So it's not going to get in the intersection. Notice that this left side part of A circle is shaded here, but not here. So it's not going to get into the intersection. My final answer is actually right there. This is just the scratch work downstairs here. This is my final answer right there. So sometimes I think it's best to take it in steps like that. Figure out what A complement looks like. Go figure out what B complement looks like, and then take the overlap of those two, the intersection of those two. Notice that the answer we just got to part E here is actually the same picture as what we just got right here. See that picture right there that we got for the complement of A union B? Happens to be the same as this picture that we got for the intersection of the two complements. Looks like the complement of the unions is the same thing as the intersection of the complements. That was actually De Morgan's law. That was one of De Morgan's laws. If you remember uh, De Morgan's laws, I think I can share that again here. We just saw a visual of the first his first law right here. Similarly, this is also true. Let's look at one that has a three-circle Venn diagram. These are a little harder, I think. So my final answer is going to show up here, but let's take it slow. It's asking us to intersect A union C with B complement. I think it is a good idea to probably figure out what does A union C look like. Let me see if I can squeeze that over here. What does A union C look like? A to get into A union C, so I'm just focusing on this part right here. You just have to be in the A circle or the C circle. So the entire A circle should definitely get shaded, and the entire C circle should definitely get shaded. Noticed I shaded the entire A circle. I also shaded the entire C circle because to get into the union of A and C, you just have to be in one circle or the other. You might be in both, but you just have to be in one or the other. We're also considering B complement here. B complement means the opposite of the B circle. That means everything not in the B circle. So don't shade the B circle, but shade everything not in the B circle. Like this stuff is not in the B circle. I'm not shading the B circle, but I am shading everything else. And that means I also have to shade the outside part here. That's what B complement would look like. I'm shading everything in the whole rectangle, but not the B circle, the opposite of the B circle. And finally, I need to intersect those two things. So we're going to intersect, remember, means take the overlap of these two things. I'm only in my final answer. This is going to be my final answer here. But in my final answer, I'm only going to draw the intersection of these two pictures. I'm only going to draw things that are shaded in both pictures at the same time. For example, you see this upper part of A, that is shaded in both pictures at the same time. So that gets into my answer. That gets part of the intersection there. What about this part? It is shaded here, but it's not shaded here. So this part's not going to get into the answer. What about the middle part? The middle part is shaded here, but it's not shaded here. The middle part does not get into the answer. What about this little left-hand part over here, A? That's shaded in this one, and it's also shaded in that one. So that does get into the answer. What about that bottom part of C down here? That is shaded here, and it is also shaded here. That does get into the final answer. The middle part does not, because although it's shaded here, it's not shaded here. This means where they overlap each other. That top part is not. This part is not. This part is not shaded in either one. How about the outside part? The outside part is shaded in this picture, but it's not shaded in this picture, so it doesn't get into my intersection. It's not going to be in my final answer. I think we do have the final answer there. We're done. Let's do another one with three circles. Those are a little bit more difficult usually. So some of the more difficult questions, I think you should just take your time, right? Although our final answer will end up here, it doesn't mean we have to do it right away. Let's take, I mean, this is not easy itself, but let's see if we can figure this part out. You might make an argument we should split this one into two steps, but let's see if we can figure this one out. And then we're going to union that with B. Well, the B part's easy. The B part is just the B circle. So let me start with that one. I can do that one. No problem. There's my B circle. What does this mean? C complement intersected with A. C complement intersected with A. That means to get into this, we have to satisfy both of these things. Like, remember, this means and. This means this has to be true and that has to be true. The part that I'm going to shade is the part of the picture that is at the same time not in C, but it is in A. Let me say that again. This means like intersection means and. It means like both of those have to be satisfied. So what I'm going to shade right here is everything that is at the same time not in C, but it is in A. Well, this part is definitely not in C, but it is in A. But I think this part here is also not in C, but it is in A. I hope that makes sense. This is all the stuff that satisfies both of those at the same time. It's everything that is at the same time not in the C circle, but it is in the A circle. So I didn't notice I didn't do the whole entire A circle because I didn't want to do the part that overlapped with C because this says C complement. I needed to do the part that was in the A circle, but not in the C circle. And that's what I drew right there. And finally, we want to union those two things to get to my final answer. Union means not the overlap. To get into the union, you just have to be shaded in one picture or the other. So my final answer is just going to be everything that I see shaded in one of the two pictures, or could be both, but it doesn't have to be. So see how this part is shaded right there? See how that part is shaded right there? The middle part is shaded here. I know the middle part is not shaded on this one, but to get into the union, you only have to be in one or the other. Like you only have to satisfy just one of the two things, not necessarily both of them. So this middle part does get shaded, even though it's not shaded here, it is shaded over here. And to get into the union, you just have to meet one of the two criteria. To get into the intersection, you have to meet both criteria. So what else? That top part of B, if we see it shaded anywhere over there on the right, it's going to make it into the answer. That's what union means. That bottom part right there. So I think we've shaded everything that is um, shaded in either picture, like at least one of the two pictures. That's what union means. Just have to meet at least one of the two criteria. Not necessarily both, but maybe both. I think that's our final answer. For the last type of problem I would like to look at, we're kind of going to kind of reverse what we just did. I gave you the shading already, and I'm asking you to write the set notation. So it's exact opposite of what we've just been doing. These are tough. And they're also tough because there might be more than one correct answer to these types of problems. Remember that De Morgan's law kind of confirms that. Um, and going back to, I know this was part of something I showed you earlier today. For example, look at these last two right here. If this was the shading we were given, it could either be A complement union B complement, or it could be the complement of A intersect B. Both of those would be good answers for this. If this was the shading we were given, the answer could either be A complement intersect B complement, or it could be the complement of A union B. I know that's kind of hard to read a little bit there, but there's definitely more than one correct answer possible for these types of problems. But let's go ahead and see what one of the answers would be. I mean, like for this first one, look at what's shaded and think about what's shaded and think about how you could describe that in set notation. That's what the question's asking. Notice that the B circle's not shaded, but everything else except the B circle is shaded. The B circle is clear, but everything else is shaded. Well, we've called that the complement of B. I mean, that's my answer. It's a good answer. Maybe we could describe that in a different way. I think it'd be pretty confusing and no reason to describe it in a different way, but it's a good answer, right? B complement is what we see shaded there. The opposite of B is what we see shaded there. look at the bottom question. It says, well, what's shaded is just that left side of A. Trying to use set notation to describe just that left side of A there. I mean, it's similar to the top one, but we don't have the outside part. So to get into this answer, you have to not be in the B circle, but it's not everything that's not in the B circle because this outside part isn't shaded. So you have to not be in the B circle, but at the same time, you do have to be in the A circle. Let me say that verbally again. Think about what's shaded. It's everything that's not in the B circle, but it is in the A circle. That's what I see shaded in this picture. Has to satisfy both of those criteria at the same time. Has to not be in the B circle, but it does have to be in the A circle. Remember, this is the notation we use when we're trying to make both, like two different things satisfied at the same time. It is in the A circle, but it's not in the B circle. I shaded everything that is in the A circle, but not in the B circle. Or vice versa. It doesn't matter what order I say that in. I shaded everything that is in the A circle, but at the same time, not in the B circle. I know that's weird and that's tough. These last couple problems are this type of problem is tough. That's what I see shaded there. Everything that is in the A circle, but not the part that's in the B circle. So both of these are satisfied in this shading here. So remember, I've been going back to these. These are kind of the 9 of the common ones that show up, at least for the two circle Venn diagrams. And actually, I think the one we just did is this one right here. That's the one we just did right now. A intersect B complement, that's this one. So sometimes this chart here will help you. This doesn't have every single possible combination, I don't think, but those are 9 of the most common ones that show up. And this is going to be our last. We are finished after this page. But let's go ahead and try to do the same thing for this. These are tough. These are not easy. Sorry, because now we got 3 circles going on at the same time. I'm not going to spend too much time on this. These can be really tough, and we could spend a lot of time on this. I just want us to see a couple like this, and then we'll wrap it up. But let me go ahead and say, notice that the C circle is like kind of not shaded. I mean, part of it is, but a lot of the C circle is not shaded. I mean, it's almost like I could say something about C complement, right? Now, that's not my final answer, of course. It's almost my final answer because if these two parts weren't shaded, then that would be my answer, right? That's not my final answer, though, because C complement would mean everything's shaded except the C circle. And so this kind of messes it up there. But we could say something like this. We say, well, okay, let's shade everything that's not in the C circle. That's what that means. But then also let's somehow shade these two parts. Those two parts are where C overlaps with A. So if I had the whole A circle shaded, that would work. If I had the whole A circle shaded, that would be the whole A circle. But then if I also shaded everything else that's not in C, that would just be the rest of the stuff. And that would get me the shading that we see right there. You know these are tough. I don't want us to stress too much about the 3 circle ones like this. The 2 circle ones definitely. I just want you to see this. I want you to be exposed to this. So I don't want to overdo this and spend too much time, but that would be a good answer for that one. And then finally, this last one, I'm going to go a little quick on this last one because it's ugly and it's not that easy. But for this last one, think about what's shaded. It's everything. Well, It has something to do with the C circle, right? I mean, the C circle is there. I mean, a little bit of the C circle is there, so let me start with that. But what else? I mean, because obviously not the whole C circle is shaded. I somehow need to like not have the A circle involved at all. So it's in the C circle, but it's where like C overlaps with B, right? You see how that's where C overlaps with B? I almost can say this. It's almost that. That's almost my answer, but that would include this part because this part in the middle is also where C overlaps with B. So that's not my final answer. I somehow want to say that I don't want that middle part. I don't want the part that's also in A. I only want the part that's in C and B at the same time, but I don't want the part here in the middle that also happens to be in the A circle. So I don't want the A circle. That's A complement. So I want those two things to be true. I want it to not be in A, and at the same time I want it to be in B, and at the same time I want it to be in C. This is just one way to say it. I could probably talk about putting those parentheses in different spots, to be honest. This is not the only correct answer for this type of question. Remember, these types of questions have more than one correct answer. But this has it not being an A. The A circle is not shaded, but I do want to shade the part that is not in A and it is in B. But if I left it just as not in A and it is in B, that would be both of these two. But I don't want both of those two shaded. So I don't want both of those two. I only want the part that overlaps with C. And that leaves us with just that last part. No, that's tough. This last page is just weird and tough. And I don't want you to stress too much over this last page, but I do want you to be exposed to some of those three circle diagrams. That comes to the end of the section. Thank you for watching.